Welcome back to Chemistry Lab. Today's topic, electrolytes and solution conductivity. Electrolytes are made up of ions which can be measured by conductivity. Conductivity is a measure of how well a solution conducts charge. Ions come from ionic compounds. For example, sodium chloride is a solid, but when you dissolve it in water, it ionizes the sodium ions and chloride ions. We use a little AQ to indicate that these are dissolved in solution. The more ions we have dissolved in water, the more conductive the solution is. If we have one sodium chloride unit, we would generate one sodium ion and one chloride ion. Right? If we had 100 sodium chloride units, we would generate 100 sodium ions and 100 chloride ions. Or if we think of this in molar terms, if we have 1 mole of sodium chloride units, which would be Avogadro's number of sodium chloride units, we would generate in water 1 mole of sodium ions and 1 mole of chloride ions. Compare that to a salt like magnesium chloride. Right? Magnesium is a group 2 metal. Magnesium chloride is also a solid when you pull it off the shelf, but when you dissolve it in water, you get magnesium ions and you're going to have 2 chloride ions for every 1 magnesium ion. So if we had 1 magnesium chloride unit, we would generate 1 magnesium ion and 2 chloride ions. If we had 100 magnesium chloride units, we would generate 100 magnesium ions and 200 chloride ions. Or if we had 1 mole, Avogadro's number of magnesium chloride units, we would generate 1 mole of magnesium ions and 2 moles of chloride ions. In other words, if we compare 1 mole of sodium chloride to 1 mole of magnesium chloride, the magnesium chloride solution will give us more ions in solution and should therefore be the more conductive solution. We should measure a higher conductivity for it. While ionic compounds are made up of ions, molecular compounds are made up of atoms. Water is a classic molecular compound made up of 2 or more nonmetal atoms. So water itself produces very little in the way of ions, but compounds that are dissolved in water will be the ones producing the ions. Any magnesium chloride that we had dissolved in the water would certainly give it, make the solution conductive. Natural bodies of water have minerals dissolved in them, and it is those minerals producing ions that create the conductivity of that water. In the lab, you will explore the conductivity of solutions and the concentrations of those solutions. You'll also look at an interesting application, saltwater intrusion. In times of drought, salt water can intrude on natural aquifers and make natural aquifer water more conductive, which can lead to agricultural problems. Don't forget to answer the pre-lab questions and have a great lab. We're in the lab now, and this is the conductivity probe that you'll be using. The box connected to it needs to be selected for the 0 to 20,000 microsiemens range, and I'm going to walk you through the calibration procedure. There are instructions in the lab manual for it, but to show you how this works, you go to the Sensors menu and you select Calibrate, and it should be on the 20,000, 0 to 20,000 range, and we're going to calibrate now. We're doing a 2-point calibration where we're going to say when the probe is in air, it should have 0 conductivity, which makes sense. And notice the voltage reading here, 0.06. Well, you don't have to write that down, but we're going to enter a 0 for our conductivity range and click Keep. And for our known value 2, we're going to use a standard solution that we have at the front of the lab. This is a 10,000 microsiemens standard solution.
put it down inside the test tube that has the solution in it. Notice our voltage has changed here. And we're going to tell the probe that we want to call this the 10,000 solution. So we put in 10,000, 1, 2, 3, there we go, 10,000, and keep. Then we're going to say OK. And it should be somewhere in that range of 10,000. There's quite a bit of error in the numbers here at the end, so it wanders around a little bit. When you're taking your readings, just kind of take something in the middle of those and go on and take the next reading.